Recently in class, we did a construction of the perpendicular bisector and a perpendicular to a line through a point that's not on a line. We used only the straight edge and the compass. Even though this is a ruler, yes, I know it's a ruler, and a lot of you guys will call it a ruler, but we're not using the measurements on the ruler, and so that is why we're not calling it a ruler. We're just using it for its straight edge to draw straight lines in between points. If we do want to have congruency, then we use this distance between the pencil and the point, and this represents a radius of a circle. When you start your perpendicular bisector construction, make sure you start with a line segment. You can call the points A and B. Don't put in any dots or anything on the ends of these. Just use the natural end of the segment after you've drawn it. Place the compass on one of the endpoints. Stretch the compass just past the middle and sweep your compass so that it intersects the line and it goes below and above the segment. Next, using the same radius, just go ahead and double check and make sure that you have the same radius. Place the point on the other endpoint and sweep your compass. You're going to get these two intersecting arcs. These arcs represent circles. I could have drawn an entire circle here centered around B, an entire circle around A, centered at A, and then we have our perpendicular bisector. So this is a line, let's call this line L, that passes through M. So just to define what we've done here, we've taken segment AB and we've made line L perpendicular to segment AB. We have also not only made the line perpendicular, but we've had it pass through the midpoint. We actually found that midpoint M, and so we know that AM is going to be congruent to MB. Later on, when we get into proving congruent triangles, I can actually show you the proof behind this perpendicular bisector by using congruent triangles. And then I can also show you that all of these constructions are only ways that we can visualize the theorems and postulates and properties that we have in geometry. For the next construction, I'm going to do a little bit of a magic trick. I bet that I can get a line that passes through this point and is also perpendicular to this line. Let me show you how. First, make a circle that's centered at C. Make sure that this circle intersects line M. Place your compass on one of the intersections, not on the endpoint of the line. This represents a line, that's why I put the arrowheads. It does not represent a segment, so this does not have an end. Now, go a little bit more than halfway of this new line. Go above and beyond. Go above and below line. Using the same radius, make an arc that goes the opposite way, that will intersect the arc that you just drew. Take your straight edge and draw a line through the intersections. Whoa, no way. Did you see that? just went right through my point C. It's interesting. That's what I wanted it to do. Let me tell you what's going on here. C has a circle that we drew, right? This is the center of this circle. These here represent the radii of this circle. These radii are congruent. So what we did was we found 2 points that were equidistant to C, and then we took the perpendicular bisector of that new segment marked off by these intersections. That's how we found the midpoint of these in order to define a segment on the line. I wish I would have come up with that. I didn't. But as you can see, we're using different postulates and properties in order to make these constructions. I think they're pretty cool. We're going to be doing some more later on in class. But for starters, let's define this. What we know is that C is on, let's call this line N. Line N, and M, line M, is perpendicular to line N.